Okay guys, let's continue solving our task, and the next task would be as following. So it calls gas station. There is an gas station along a circular road where the amount of gas at its station is gas I. Okay. You have a car with a limited gas tank, and it costs of gas to travel from I station to the next I+1 station. You begin the journey with an empty tank at one of the gas stations. Given two integers, gas and cost, return the starting gas station's index if you can travel around the circuit once in the clock's y direction. Otherwise, return -1. If there exists a solution, it's guaranteed to be unique. If there exists, so it can be not exist solution. So for example, here we have a gas 1, 2, 3, 4, 5, and some costs. So first, we need to find the maximum gas with the lowest cost. So for example, we have gas 5 with cost 2, right? So we go 1, 2, 3, 4, and 5. So okay, and here start the station 3, index 3. Okay, so we start with this one, and the price is 1. And fill up with 4 units of gas. And your tank becomes 0 plus 4, it would be 4. Travel to the station 4, your tank 4 minus 1 plus 5 equal 8. Once again. Okay, so I start with 4. Okay, and cost 1. Fill up with 4 units of gas. Your tank would be 0 plus 4. Okay. Okay, so we start from 4, then go to 5, minus price, I believe, right? Then it will be 8. Or minus 1 plus 5, 8. Okay, so from 5, so we have 8. We know that cost it would be 2. So 8 travel, the cost is 5. Your gas is just enough to travel back to station 3. Return 3 as the starting index. You can start at station 0 or 1, as there is not enough gas to travel to the next station. Let's start at the station 2 and fill up with 4 units of gas. Travel to the station 0. Your tank would be 4 minus 3. 4 minus 3, 1 and plus 2. then 3 minus 3 and plus 3. 3. Okay. You cannot travel back to station 2 as it's required 4 units of gas, but you only have 3. Therefore, you can't travel around the circuit once metro. Okay. So what can we do here? So we have a gas. We have a gas and costs. So if we'll try to find the maximum gas like here, and then try to travel. Right, so here will be 5 minus 2 plus 3. 5 minus 2 plus 1. It would be 4. Then 4 minus 3 plus 2. It would be 3. But then from here I cannot travel again. Okay. So actually what I need to do is try every options. Here. Regarding constraints, I have really big constraints. So it would be not feasible to try all these options actually. Yeah, because it would be squared and it would be 10 on 10, 10 on 10's power. So yeah, quite big enough. Maybe it would be better to find first the margin. So the margin between 1 and 3 would be 2, 2 and 4, 2, 3 and 5, 2, 4 and 1, 3, and 5 and 2, 3, actually. And in this case, we have 2 options. And we need to try both of them. Here we have margin 1, 1, and 1. So we have all 3 options here. Yeah, but it still not works. It still not works. Can I try, for example, if I travel from 1, if I take 1, and its cost would be 3. So I cannot start with 1. Also cannot start with 3. Yeah, so I cannot start with all of these things because, yeah, the gas is less than. So I definitely should start with 4 or 5. So when I start with 5, I'm doing like 5 minus 2 plus 1. Here's 2, 3, 4. We still cannot start with 3. Also cannot start, so I can start only with 4. Okay. So I can start only with 4. Okay, so let's try to do this. So what can we do? So we have some gas and cost connections, right? So let's imagine that we have nodes, and this node has gas and cost, and they are connected between each other, so it will be like linked list. And nodes like 2 and 4, and so on. And we create this linked list. Then we try to find the current node, actually. And yeah, so when I have this linked list, I can make it like a circular, right? And from this nodes, I will find all nodes that is greater, and then we'll try to iterate from them and check if I can do this or not. Yeah. So let's do this. Let's have a record node with integer gas and integer cost, and also node next. So we start with first node. It will be our root with gas equal 0 and cost equal 0. Okay, and the next one will be null. So we have our root. Then we iterate over first element, and let's say like gas length I++. So what we do here, we create a new node with I. And yeah, we have to create the circular. So let's have current, it will be root. And here we should do like if I is equal to gas length -1, so it's our last node. And here it will be not our last node. So when we have a last node, we create this n node, and here n node next would be equal to root. Okay. Here, yeah. So here our current next would be equal to n node. And current will be equal to n node. Here I think should be also done here. Or I think even something like this. Then we should create our node list. And how we will do this? Yeah, so we will do this right over here, and and we will check like if root gas is greater than cost, greater or equal to cost, then end list and root. And the same I should do for every end node. So I check if end node root cost end node. All right, so now I should go from each of this selected node and yeah, and here return -1 because I haven't found any node that works. So it will be selected node. And I should check if it works. If is valid, selected node. Yeah, if it's valid, then I should return index, right? So start at 3. Okay, so let's also have an index here. Here it will be 0. Here it will be I. And here we should return selected node index. Let's implement this private boolean is valid function. And here is valid function, we have our node. And yeah, so our current node will be node while current not equal to to node, we are doing some stuff. Here we should return true. So how we do this stuff? So we have our current node, and we have gas that we take from current node, right? And this gas, it will be, let's have it total current gas minus current cost. Then and also, yeah, we went to the next node actually. So we put gas, we have our cost, and we left with some gas when we came to gas station, right? So for example, here we have 4 minus 1, it would be 3, and we came to gas station. And if our total is less than 0, we return false. Here we came to our gas station, So our current becomes current next. And our total, we populate with current gas, right? We populate with current gas, and we are going to the next direction with minus current C. All right, so let's check. Cannot assign. Yeah, so the problem here again, we need to have class in the node. Yeah, and we need to have it as a fields. Here we have to initialize these fields. Okay. Okay. 2 expected minus 1, but it was 2. Okay, so let's check. So with case 1, we check that it will be 3. With this one, 2, 3, 4, we start with this node. We have selected node, and we are checking if it's valid. So we have current node, so it would be 4 minus 3. Yeah, so total would be 1. And we came to this station, we are getting 2, right? 2, it would be 3. Yeah, so 2, it would be 3. And minus 3, it it becomes 0. And go to the station, and here I should return if total is greater or equal to 0. Let's calculate system out print line. Here we have index current index plus total equal to total. Oh, yeah. So, here should be next. Current. Here I take node, and this one would be next. So I'm doing something like this. Okay, submit. null pointer 5, line 35, cannot read field index because it's null. Yeah, I think here we should also check if gas length equal to 1, then I should return yeah, I should return 5 and 4. Yeah, so here I should return like gas 0 is greater or equal to cost 0. And yeah, 0 as a rest lines. Something like this. Output limit, so we need to remove this one. Yeah, and we see a lot of, yeah, so it could be time limit actually. Yeah, so we have time limit exception here, and yeah, so a lot of zeros. And then 2. Okay. Okay, 2. Okay, I'm thinking, how can I work with such test case actually? So we have a lot of zeros. And we need to omit the zeros somehow. All right, what if we just do it like this? Okay, now it's accepted. All right, so we solved this question, but it's really slow. Let's check solutions. Okay, so let's see in brute force solution. Okay, so I think that's it. Thank you.